as we discussed before, when you're trying to find where a function has a horizontal tangent line, that is the same as trying to figure out where the derivative is equal to 0. So what we need to do to find the x coordinates where we have a horizontal tangent is first find the derivative and then set it equal to 0. And you'll notice in finding the derivative for this function that you have parentheses to a number, so that means we need to use our general power rule. All right, so here we go with the general power rule. We will have y prime is equal to 8 times x minus 6 over x. Subtract 1 to get the 7, and then we have to multiply that by the derivative of the inner function. Now you'll notice that the x, of course, its derivative is 1. This minus 6 over x, I would kind of go off to the side and rewrite that as negative 6x to the negative 1. And then say to myself, once I have that rewritten, that I would use the power rule on that. So I would bring down the negative 1 to get a positive 6x to the negative 2. Okay, so that would be our derivative of the inner function here in parentheses. Now, at that point, we want to set our derivative equal to 0 and solve. Now, please notice there's a very special structure here. You have factored form. So this is already factored. And again, you know it's already factored because you have parentheses is equal to 0. So what you can do is you can just set these factors equal to 0. So you would just set 8 equal to 0, nothing comes from that. And then you would set your x minus 6 over x to the 7th equal to 0. And the other factor, 1 plus 6x to the negative 2 equal to 0. Now, do note that you can easily get rid of the 7th power by taking the 7th root of both sides. And when you take the 7th root of 0, you will just have 0 on the right-hand side still, and then the x minus 6 over x. Okay, so let's focus on solving this equation. I think what most people would do is they would move the 6 over x to the other side. So that would give you x is equal to 6 over x, and then multiply both sides by x, and that cancels. Now, when you are doing that, you are assuming that x is not equal to 0. So that is your assumption if you cancel out these x's over here. And that would then give you, take the square root, x is equal to plus or minus the square root of 6. All right, now over here on the other side, what we would solve for is we would probably move this x to the negative 2 down to the denominator to start. And then the same way, move over to one side, the negative 6 over x squared, and then multiply both sides by x squared. And again, when you do that, you're assuming that your x is not equal to 0 because you're going to cancel out the x squared on this side, so that means x cannot be equal to 0. Now, you will notice here that x squared is equal to negative 1. If you were to take the square root of both sides here, you would get x is equal to plus or minus I square root of 6. And of course, anytime we talk about imaginary numbers and functions and graphs, if you think about drawing the graph, where are you going to graph I is equal to the square root of 6? So because there is not a place to graph this I square root of 6 in our real Cartesian coordinate system, we ignore that solution, okay? So our only answer here would be x is equal to plus or minus square root of 6. I do want to just say one other thing about this assumption that x cannot be equal to 0. That assumption is true because if you look at the original problem you had x minus 6 over x to the 8th power. And by writing that, that is assuming that x, the denominator, cannot be equal to 0. So when you cross that out, you are not crossing out a solution because the original function as it is given assumes that x cannot be equal to 0. Because if x was equal to 0, then you would have a 0 in the denominator. Okay, so our answer would be that there's two x coordinates plus or minus square root of 6.